I've got some slides to show you. I now have rudders on my micro Skyhunter. I'll have links in the show notes to the kit version. You can't get the plug and fly version anymore, but it is one of my all-time favorite planes. It's a fantastic airframe. The one that I have, that I've had for years, is made out of EPO foam, but the ones that I have links to in the show notes are made out of EPP foam, which will be even more durable than EPO foam. I'm flying it with a Tat2 4S 1050 milliamp hour LiPo. I think it's 95C. And I've always had to, it weighs about 125 grams, and I've always had to shove that battery pretty far back. I barely get the battery strap over the edge of it in order to get the CG. Now that I have these dual rudder servos, the rudders, the linkage, I'm now able to move that battery forward where I can secure it better. So it's worked out all around. I've never been able to do hammerheads, stall turns with this plane because it just comes as a plug and fly as a bank and yank. And I've been wanting to put rudders on it for a very long time. I'd always just flown this plane with a standard 6-channel receiver or 4-channel receiver, no gyro. The last flight session I had on this plane, I finally put a Byme-A gyro in it, and that worked out great. Now I've got a parachute button in case I need one, and in case I do something really stupid. And more importantly, I've got wind mitigation on it now because I am typically flying in some wind and some gust. And having that Byme gyro in wind mitigation mode so it smooths that out really makes flights much more enjoyable than fighting the wind all the time. All right, so the material that I fabricated these two rudders out of, the control surfaces, is the plastic lid off of one of these Coffee Mate containers. And these are large containers. I buy these at Costco because it's so much cheaper to buy it in a large container like that than it is in a standard grocery store. So I saved those lids because I use them for all kinds of things. And I pulled out one of those lids the other day. I've got a little box of just plastic, plastic bits and pieces, including lids, that I use for fabricating different things. And I pulled one of these out and I thought, that is going to make some good rudder material. It's pretty thick plastic and it's pretty rigid. And the trailing edge of the vertical stabilizers, they're tapered pretty thin. So using standard foam wasn't going to work out, but that plastic I think is going to work out absolutely fine. And I always try to repurpose household material or material from planes that I have retired so that you don't have to buy that stuff. It makes it so much less expensive to maintain this hobby and to perform modifications like this if you just use household material for it or scrap from previous planes. So I save my foam too. All right, so here is a close-up of the plastic rudder from that lid, dual rudders, plastic control horns, and I used strips of fiber tape to make the hinges. And I put fiber tape on the inside and the outside and then pinched the centers together, because what does tape stick to the best? Better than anything else? Itself. So I pinched those centers together, and that made an extremely solid couple of tape hinges there. I'm not getting any movement, vertically in the control in the rudder itself. The tape control hinges are extremely solid, and they have very, very minimal resistance. So those 2.5 gram servos I've got on there, I think are gonna have plenty of torque for these, as long as I'm not going full bore when I actuate them. And here's the inside. Also, especially when you have a dual setup like this dual rudder setup, I always like using linkage stops better than those plastic clevises. I've had those plastic clevises separate on me before, even having the little silicone retaining ring on it, especially when you're using those on a plane like this that has tons of power and tons of speed. Those plastic clevises just, sometimes they just won't hold. They'll pull apart no matter what you do. I had that happen on me on my Z84 wing. The first big crash I had with it, I was screaming vertical with it and doing vertical rolls as I was climbing, and one of the Elevon plastic clevises separated on it, even though I had one of those retaining rings on the clevis. So unless it's a very, very small, lightweight plane that's not all that fast, I always try to use linkage stops. Plus, a linkage stop makes it much easier to get. Once you get your center position on your control arm on your servo, and you want to get your control surface centered up, it makes it so much easier to just loosen up that retaining screw on the linkage stop just a little bit, just enough to move the control surface without moving the servo, and then quickly tighten it back down again. I mean, it makes it so much faster and so much easier to use those. Okay, so here's a top picture of the servos, where I have the servos mounted. And the control rods that I use, they're pretty thin, they're pretty flexible, and they're pretty long, going from the trailing edge of the main wing all the way back to the control horns on the rudder. So that's a pretty long stretch for those really thin control rods. So what I did was I took two of these little nylon spacers, and I ran the control rods through those, and I positioned those midway between the control arms on the servos and the control horns on the rudders. I zip tied them down to the square carbon tubing that forms the two booms, and then also put glue along the sides so that they wouldn't pivot. I think that's going to work out great. Just testing them on the ground, everything structurally, everything looks like it's good and solid. I don't think I'm going to get any flexing in the servo control rods with that bracing on there. So something else that I just a piece of hardware that I had laying around. So, and I wanted to show you up here, I have the 2 blocks of 10 millimeter thick EPP foam. This is foam that I saved from a 3D profile plane that I had. And it had a main wing carbon spar, square tube carbon spar, just like the booms on this micro Skyhunter, as the main spar in the main wing. So the channel was already cut. So all I had to do was cut a couple of blocks out of that wing foam from that plane that I had retired, and it saddled right over top of that square carbon tube, both of the booms. So I glued those two pieces to the carbon boom, and then that gave me, triple or quadruple the area in which to attach these servos to that foam, rather than just to the square carbon tube. All right, so that's that. Here's the look at the bottom side. Just the servo wires were just the right length to bring them into the fuselage, and then I took a servo Y cable to patch them into, and then plug that into the rudder channel on the Byme-A gyro. And so I've got one side that's glued into the EPP foam blocks there, and then the end of it is glued onto the support for the two booms, for the two elevator booms, rudder booms. And I think that's a really good position for those, because the way they're positioned, if you look at how wide these curved supports are right here, it's going to produce a very, very minimal amount of drag where those servos are located, left to right in that little pocket and top to bottom. So I think the airflow is going to go around them really, really well. Here's a picture of the top side of it with the foam blocks. You can see where everything is located. in relation to the motor and the prop. Plenty of space in there. All right, we're back to the beginning. Okay, so I'm really happy about getting a gyro in this plane. I am really happy about now having rudders on it rather than just have it bank and yank. I think that this is this dual servo setup, I think, is going to work out really well. So stay tuned for the test flight that I'll be conducting as soon as I have the weather. All right, that's a wrap on this episode, and I'll see you next time in the Tinkerz Lab.